Good morning. In this video, we will see the practicals determination of soil pH. Soil pH is otherwise called as soil reaction. So, myself Dr. R. SINGARAVEL, Professor, Department of Soil Science and Agricultural Chemistry, ANNAMALAI University. Soil reaction, many of us know the definition. This you have studied in your schooling days. pH is defined as the negative logarithm of hydrogen ion concentration, or simply the logarithm of reciprocal of hydrogen ion concentration. So, in a system, when you measure the activity of hydrogen ion or the concentration of hydrogen ion, then it is called as the pH. The pH is defined as, and it is negative logarithm of hydrogen ion or log 1 by H plus. pH of the soil or pH usually varies from 0 to 14. pH varies from 0 to 14. Less than 7 is acidic and then 7 is neutral, greater than 7 is alkaline. pH is determined in soil by three ways. It serves as an approximate measure of degree of base saturation or degree of calcium saturation. So, bases in the soil, calcium, magnesium, sodium, potassium, these are all basic cation. When they dominate the soil, then the pH of the soil will be above 7. When the acidic ion, hydrogen, aluminum predominates in the soil, then the soil becomes acidic, pH will be less than 7. So, bases are very important, for they are also nutrients, calcium, magnesium, potassium. So, base saturation, more the base saturation capacity, more will be the fertility of the soil. So, it gives an approximate estimation of the base saturation percentage of the soil. When you estimate the pH of the soil, it gives an estimate of the base saturation percentage. And also it serves as an approximate guide for liming, or when the soil is acidic, then we have to go for liming to bring the soil to neutral soil. Then it is also done to characterize, to classify the soil. We have to find out the pH of the soil, very important parameter. Whether that soil is acidic, alkaline or neutral, we have to find out the pH of the soil. For this reason, the pH estimation is very important. So, pH is nothing but measuring the concentration of hydrogen ion in water or soil or in any biological fluid. The measurement method of hydrogen ion activity or hydrogen ion concentration can be classified into calorimetric method and electrochemical method. By two methods you can find out or you can determine the pH of the soil or pH of pH. When speed is primary and accuracy is secondary, you can choose calorimetric method. When the speed is primary and accuracy is secondary, then calorimetric method can be chosen. But where accuracy is primary, you can choose the electrometric method for determining the pH. Electrometric method, the method is based on the Nernst theory of potential, and the pH is measured directly as pH value by the use of potentiometer. We employ potentiometer to develop the potential developed at the hydrogen ion electrode, which is the measure of pH. So, it is based on the Nernst theory of potential. The most accurate method of determining soil pH is pH meter. You can employ pH meter to determine the soil pH. The principle involved in pH determination is the determination of pH amounts to the determination of the potential developed when a hydrogen electrode is dipped in solution of hydrogen ion. When you dip the hydrogen electrode in a solution containing hydrogen ion, a small electric potential is developed. the electrode measures the potential of the solution, especially the hydrogen ion solution, so which is the pH. Standard buffer solution. So, before taking up the reading using pH meter, you have to standardize the instrument, as I said. So, on every occasion before the use, pH meter must be calibrated or standardized using buffer solution. So, we need at least 2 buffer solution, one at low pH, one at a high pH value. Usually we prepare potassium hydrogen phthalate 0.05 molar solution, which gives pH value of 4.001. So, for the preparation of potassium hydrogen phthalate, you dissolve 10.2 gram of analytical grade potassium hydrogen phthalate and then make up to 1 liter using distilled water. So, this will give you a pH of 4.001 or 4.0. Potassium hydrogen phthalate 0.05 molar solution is prepared by dissolving 10.21 gram of potassium hydrogen phthalate in 1 liter of water. For high pH range, we used to prepare borax solution 0.01 molar, which gives a pH value of 9.22, 9.2. So, dissolve 3.81 gram of the borax solution in 1 liter of water. This gives you 9.22 pH value. Before taking out the pH using the pH meter, you have to standardize the instrument for the measurement of pH. So, how to standardize the instrument? First step, switch the pH meter, switch on the pH meter. Then you run the pH meter for a few minutes to half an hour or 1 hour to warm up, to allow the meter to run up for getting the instrument warmed up. Then wash the electrode with the stream of distilled water. Remove the excess water by gently tapping the bulb. In the pH meter, we have the electrode. Now dip the pH meter into the solution, wash the electrode with the distilled water, wash the electrode, then take out the electrode and then wipe out the excess moisture present outside using the filter paper. Then check the calomel electrode. There are 2 electrodes, one is glass electrode, another one is calomel electrode. Nowadays we have the combined electrode now. So, you dip the electrodes, calomel electrode, check the saturated KCl is full in that electrode. Then afterwards set the temperature to the solution temperature. Find out the temperature of the solution and set the knob of the pH meter for the temperature. Then dip the electrode in the pH buffer solution. Then dip the electrode in the buffer solution. Adjust the potentiometer to show the theoretical pH value. So, we have to prepare a standard buffer solution before taking up the reading. We prefer the low level pH around 4 one buffer solution and high level around 9 one buffer solution. Now, you feed the pH 4 buffer solution and adjust the knob to read the value 4 or adjust the knob to read 4. Then take out the electrode, wash it with water, then wipe out the excess moisture outside. Then you put the higher buffer solution 9.2, then dip the electrode, adjust the knob to read 9 or 9.2. In this way you standardize the instrument. I repeat, dip the electrode in the low pH buffer solution, adjust the point or dial to show the theoretical pH value. That is, theoretical pH value is when you feed 4 buffer 4, then adjust the reading for 4. Then switch to the rest position. After adjusting the reading to 4, bring the knob to the rest position. Then wash the electrode, remove the excess moisture outside by wiping out with a glass filter paper. Then repeat the process with a high pH buffer. As I said, you put the high pH buffer and then adjust the reading, then bring to the normal position. Recheck again by feeding 4, the instrument should read 4. By feeding 9 or 9.2 buffer, the instrument should read 9.2. So when it is okay, then the instrument is standardized. The procedure for finding out the pH of the soil: you have to prepare soil paste, soil saturation paste, or soil water extract, or soil water ratio. There are different ratio you can employ, 1:2.5, 1:5, depending upon the purpose. For routine analysis, we use 1:2 ratio, one part soil and then 2.5 parts water. Weigh 20 gram of air dry soil and transfer to a 100 ml beaker. Add 50 ml of distilled water. Stir well with a glass rod intermittently for half an hour. Measure the pH in pH meter using glass and reference electrode. Test the pH meter with the buffer solution before the use, that is, standardize the pH meter, then you take up the reading. Very simple procedure. So you take up 20 gram of soil, 20 gram soil, you transfer to a 100 ml beaker, transfer to a 100 ml beaker soil, then add, second step, add 50 ml of water, 50 ml water, you add, water you add, then put a glass rod, stir it intermittently for half an hour. Stir it, keep some time, then afterwards stir it, then like that you keep it for half an hour. After that, you read the pH using pH meter by doing standardization of buffer solution. Thank you.